Okay, so welcome back to the programming bootcamp. This is the second video that we are recording. In any case, if you have missed the previous parts, then it's better to go back and start from there. This is the introductory slide. That's the website where you can find the slides. And my name is Gabor Szabó, and from the CodeMaven website. And hi, Nora. We're going jumping ahead to the point where we had the break earlier. So we talked about a little bit about Python being open source, and then we can get the source code if you really want. And well, a few years after getting into Python, some people actually start doing this because it's so interesting. The next thing that I would like to talk about is versions of Python. So in the field around you, actually, I don't know, I can enlarge the fonts. Okay, so out in the market, there are two main versions of Python, the Python 2 series and the Python 3 series. And I'm talking a little bit about it, even though, I mean, right now, if you're starting using Python, then you should definitely use version 3. We are going to look at version 3.8, but it doesn't really matter if it's 3.7 or 6 or 8. Obviously, the newer the version, there probably are better and newer features, but for the majority of things that we do, older versions are okay as well. The big difference between Python 2 and Python 3, so I mentioned that there is also this Python 2 thing. So Python 2 was the previous version, a really long-running version, I think, from the beginning of 2000, and it basically retired at the end of this year, or at the beginning of this year, and it's not maintained anymore. And I'm talking about this because in many environments, you will find Python 2 already used, and many programs using Python 2, and people are in not every place would like to switch to Python 3. So you might need to be aware of the differences between the two versions of the language. They're not huge, but if you fall in the trap of between these differences, then you'll encounter issues. So during the slides, I'll point out a couple of these differences. Another important thing why it's good to know these differences, even though you might only write Python 3, which is the recommended one, is because when you search for solutions on the internet, you will encounter lots of solutions for issues that you encounter. You will find lots of solutions that were written 10 years ago, and therefore they were using the Python 2 syntax. And then you copy paste it and it won't work on your Python 3 version. But if you know how to recognize the Python 2, Python 3 differences, then you probably will be able to fix these small things, the differences, and make that program work. So that's why it's quite important, I think, sorry, I bring this thing lower here, to know the differences. But in general, what I'm saying is that if you have any new project started with Python 3, if you have to work with Python 2, then I mean, most of the stuff will still work with Python 2 as well. Okay, slightly small differences. Okay, so how do we get Python, the compiler? I mean, you can have it on Microsoft Windows or Linux or Apple Mac OS. So the next slide is I just a quick explanation about the Linux. So in Linux, you usually have it installed. You usually have it installed in a location called USR bin Python, and you also have something called USR bin Python 3. For historical reasons, the version that is called Python is of the Python 2 version, okay, because that was around there for many years, and the maintainers of Linux distributions don't want to change that suddenly to Python 3, but there is something which is called Python 3, which is what we usually want. If it's not there, then you can install it with your package management system usually, which is either yum or apt-get, depending on what kind of Linux you have. If you don't have Linux, then just don't worry about all this thing for now. And alternatively, you can also use the Anaconda package that we'll see in a second, because that's what we're going to use in Windows anyway. Okay, so that's what you can use in Linux. Mac OS, there too, you probably have Python installed in USR bin Python and Python 3 in the similar location. If not, then my recommendation is to go and use the Homebrew tool. I'll just show you a second. Sorry. So Homebrew is a tool especially for Mac, but apparently also for Linux, but it's especially for Mac in order to install more open source packages. So on a Mac, you would normally use the Mac installer system, whatever it's called. I forgot its name. It's like like on your mobile phone, you have the Google Play. So the similarity you have in Mac. But for open source stuff, the recommended way is to install Homebrew first and then use Homebrew to install these packages. So if I go back, you would probably install Homebrew first, and then you would say something like brew install Python 3, and that would install Python 3 for you. Okay. The alternative here too is to use the Anaconda with the distribution, which is called Anaconda with Python. For Windows, well, actually, this is now a little bit different than when I originally prepared the slides, but we'll go with an Anaconda version. So here we have two major ways to install, because on Windows you don't have Python. It doesn't come with Python. Actually, these days even Windows can come with Python, but I've never used that Python, and I think I don't recommend it. Well, for at least because I've never used it. So I mentioned, right, that Python is an open source program. So there are some people who write this program and then they distribute the source code, and then they also go distribute a compiled version of the source code. So this is back to the same place. This is where you can download. So this is the website of python.org, and here you can download the latest version of Python, especially for Windows or Linux or Mac or other operating systems. So that's already the tool that can run your Python programs. And this is a package. It is what's called a packaging. We can also see the icon here. Nice. And so it's a package. So you took the source code, they took the source code, compiled it, created a package that you can install. Similarly, there is this group, it's a company basically, that creates Anaconda Python. Where is this? Here, this is. So Anaconda, for the chemists, is basically a big snake, right? So yeah, I learned it from when I was teaching biologists. So Anaconda is a distribution again. So it's a package that you can install that contains in itself Python, an editor, all kind of other tools, all kind of extra libraries of Python. So it's basically the same Python, but with all kind of extras, and it's especially designed for scientific programming. So it includes all kind of packages that's especially important for scientific work. So they have a free version. There's also something that costs money. I never tried that one. If you go to this, the products on the website, actually, go to the main website of Anaconda, and then you go to products and individual editions. That's where you get the thing, and then you click on download. Yeah, it brings me there. And here you can select which operating system you would like to use. And for each operating system, they offer right now they offer Python 3.8 because that's most of the latest. If I go back for a second to this slide, you can see that this is actually 3.8.5 on the Python website. I don't know which sub number is here. They only say 3.8. But these are usually really, really minor differences. So at least for the foreseeable future, it doesn't really matter. Okay. What matters a little bit more, obviously the operating system, but it's whether it's 64-bit or 32-bit. And basically 32-bit, it's we'll talk about it a little bit later. It's basically how the computer works, and old computers use 32-bit, and the newer ones, mainly I think it's about 8 or 10 years more or less, all of the new computers are already using 64-bit. So it's most likely that you will have a computer that can use the 64-bit version. So that's what I recommend. And in the rare cases where you have an old computer, then you might need a 32-bit version. But that's it. So here you come, and then you can download. This is going to be an exe file, as I can see, and then you run it, and then there is a question there. Okay, and we have to discuss this. Yeah. So when you install it, I actually just installed it an hour ago. It takes some time, so I don't want to run it again because it takes some time. But at the beginning of the installation, it asks you where to install it. And by default, it tries to install in your home directory. But my home directory, as you might recall, where is it? So if you go back, so my home directory is Gabor space Sabo. And Anaconda, as many other applications, don't like these spaces or any special characters. So what I did is I went to the local disk C, and I created here inside, I right-click a new folder. So I created a directory called Gabor. Doesn't really matter. And then when Anaconda asked me where to install it, I told it to install in C Gabor Anaconda 3. Okay, and I started to move over some of my files here. That's another issue. In general, it's better to use directories that are directory passes that don't have any special character, only Latin characters, no Hungarian accent characters, and no Arabic or Hebrew letters or any other strange characters, because many applications can handle that, but sometimes these cause problem, and we have enough problems, so you don't need to make more. So that's a general recommendation, to try to use Latin letters, digits, and underscore. I think these are the characters that are welcome. The rest is slightly more problematic. Okay, so let's say we installed Anaconda, and then first of all, we would like to verify that we installed it. So for this, I click on the Windows key again, and here I can type in Anaconda, and then I can open the Anaconda prompt. Okay, so don't open the Anaconda Navigator. There are a couple of other things. You can also use the PowerShell if that's what you like, if someone knows what the PowerShell is. I am at one point you might look at that. It's more or less the same for all purposes, but we can use the Anaconda prompt, which is a window just like the CMD that I showed you. This comes with the default black background, so maybe we're going to change it. But here now I can type in Python -V, and it will tell me what is the version of Python. If it doesn't tell me the version of Python, and now you can see it's 3.8.3. So it's not exactly the latest, because the latest on the Python website is 3.8.5. But again, it doesn't really matter. Up till an hour ago or 2 hours ago, before we started the video, I had 3.7 something. So it doesn't really matter. So this is how I can run Python and ask Python to print out the version number. Just note that I type in capital V, because if you type in lowercase v, that sometimes happens, then this is what you get. Did you see it? I'll show it again. So clean screen, really nice. I run this, and this is what I get. Okay, and what happens here is Python prints out all kind of internal information, and again gets me into what we call the interactive shell. And I'm going to talk about the interactive shell because it's a powerful thing, but that at this point we didn't want that. The way to exit that is just to type in exit with parentheses after it. So I scroll back up to show you again. Maybe I can. Here, this is how I type it. And then it printed out even more stuff. And then got me back to the original prompt. So this is what we call the prompt. Because it prompts me that now it's my turn to type in some stuff. Okay, so this is how I can verify that actually I got Anaconda installed properly. Now I think if I go to the CMD, if I type in CMD and I type in Python -V, it gives me nothing because the CMD can't find the installed Python. It could be configured, but at this point I don't. It's not that interesting. So I just leave this window, I close this window. This one I can also configure. So the same way, I think I can set the properties and then the colors, and I can change here to have white background. Actually, how do I change it? Let's make it white background, and the screen test, let's make it black. And it didn't change. Oh, it did. If I exit now and run it again, Anaconda, now it's white, or white-ish sort of, not exactly white. Okay, and then you can change also the fonts and stuff, so it will be easier for you to work. Okay, and that's, I didn't say it at the beginning, but that's a huge, I talked about the keyboard and the shortcuts. It's a huge thing for people using the computers, and I see many people who don't do this, is to set up your environment to be comfortable for you. Okay, it's not only about having a comfortable chair and screen, but also that the screen size is right, or the window size. I see many people who get this window opened like this, and then they keep typing in this, and they don't never enlarge it, or whatever, resize it, or they use small fonts or whatever. So just make these changes. The investment is worth it, because the frustration from having bad environments is horrible. Okay, so we have now the Python compiler or interpreter. The other thing that we need is an editor. So here I have a long list of various editors for Linux, Windows, and Mac. And then we also have these IDEs. And at this point, I'm going to do the hard way things a little bit, okay? But in a way that I think it's more, in the end, it's better, because you learn more the basics. So for Windows, I would definitely recommend here to download Notepad++. Okay, I can click there. It's an open source editor, what's called a programmer's editor. So you come here, and then somewhere you can find the download button. I think it's here. And that now is really strange. For some reason, they just list all of them. Okay, stand with Hong Kong, interesting. So also political messages here. You just download the latest usually, and install it. And once you install it, when you open it again, it usually checks whether it has a newer version and offers you to download the newer version anyway. So that's a simple editor. But it's what called a programmer's editor. So it has all kinds of really nice features, but it doesn't deeply understand what Python is, and it cannot really run Python from inside. Okay, or at least I don't do it. Maybe it could, but that's not what I would like to do. So that's, for example, for Windows. If I go back for Mac, there are all kind of editors. Some of them are free, some of them cost money. I don't mind. For Linux, if you are a Linux user and you know Emacs or one of the editors from the VI family, then feel free to use that. If not, then there are all kind of other editors which are more which are similar to Notepad kind editors. Then use those. Doesn't really matter at this point. In the end, what I'm suggesting that you use the text editor that you are comfortable with. So if you already have a text editor, whatever, let's say if you already use UltraEdit, then just use UltraEdit, because that's what you already got used to. I'm not saying you need anything else. When we're going to get to the IDEs, then it's going to be interesting, because they are much more powerful about Python, or knowing about Python. Okay, so some more background here. Maybe I should just stop here and start writing code. But a little bit more background. So documentation. The documentation is on the Python website. So I can click here, and it's opened here. There's the documentation. So you can see docs.python.org, and it by default, or it went to the version 3, and inside you can actually pick up which version you would like to read. So if you are using Python 3.7, for example, then it might be better to use the documentation of that. Even though, again, the differences are really, really not big. But if you fall on exactly that issue that was changed between two versions, and then it's going to be really frustrating that you copy from the documentation and it doesn't work, and just because that was exactly that really, really small thing that changed. Obviously, there is also the documentation for 2.7, which is the latest version of the 2 series, in case you are stuck there and that's what you need to use. I usually don't get to the documentation directly. What I do is use one of the search engines to type in whatever I'm looking for, and it usually, if the documentation is the thing that answers my question, it will bring me there. So it's just regular search. So these are the big search engines: Google, Bing, and DuckDuckGo. If you're not familiar with DuckDuckGo, in case you are not, then this is a search engine. You should be more familiar with this image, yeah. So this is just a search engine that provides you more privacy, okay, which is really important, but that's not our subject right now. Another thing that I wanted to show you, so obviously I recommend that you can also visit the CodeMaven website and look for help there, but Stack Overflow. So Nora, do you know Stack Overflow? No? Okay, so that's it's like the programmer's heaven, but others don't really know. There are still other sites for other subjects, but this is a place where you can ask questions, and people are eager to answer your technical questions. Okay, so this is for programming usually. Even better, most likely that someone has already asked that question that you are asking, and someone already gave you the answer here. So normally you wouldn't probably come to Stack Overflow directly unless you would like to ask a question. Normally you would just search for something. So I don't know, I should have something. I don't know if I have here an example. No, I don't have an example here. So let's say Python random. I'm not sure if this can give me just. So the thing is that if I search for Python and random, looking for some random number generator, then it will bring me to the documentation. So you can see that this on the website of the documentation. On the other hand, if I search for, now I don't have any example, but when we get there, when we encounter some problem, I will show you exactly how can you get search for for some help, and then how can you evaluate things when you get onto the Stack Overflow. Because just getting there, it's one thing. Understanding what is how to pick up the solution from there, it's another thing that's good to know. Okay, program types. So that was the documentation and how to get help, basically. Program types. So I mentioned that you have all these program types that you probably are familiar with. So the desktop applications that it mentioned, like Word and Excel and Firefox and Chrome, which are desktop applications by themselves. Mobile applications, of course, that you have on your mobile phone. There are something which called the embedded software, embedded applications. So this could be a software that runs your car, for example, or in the future it is going to be installed on your shoelace, and I don't know, everywhere. So these are called embedded softwares, and usually you don't use Python in these places because Python is way too big for these locations. You don't. Okay, so desktop applications, you could use Python, but you usually don't. So you rarely use. Usually what you'd have, if you have a Python program and you would like to have it a GUI, then you can create a GUI in Python. But if the main project is to create some GUI, some desktop application, then probably there are languages that are better fit for that. Mobile applications, you almost never write in Python. Okay, so the thing that runs on mobile phones. Embedded applications, again, not in Python. Web applications, that's the part that actually gives you the service. Okay, so when you go to Google, for example, or then some program runs on the other side, and that can be written in Python. And in actually many websites, the backend, what we call the backend, is written in Python. So all these web applications, I don't know, Dropbox, I think one of the famous examples. So I think Dropbox is basically all the backend is written in Python. So these are web applications. Then there are what we call command line applications, and that's what we are going to focus on. So the things that you run on the command line. So you don't need any UI for it, anything visual. You just, they are usually something like, okay, here is a file, an Excel file. Please do some work on it and create another Excel file with some graphs in it, or just create some nice picture of it. And that's, you don't have a GUI for it. And then you can create a GUI. And actually, one of the least recent courses I had, I saw that people wrote projects, even though I didn't teach the GUI yet, they learned by themselves and created GUI for their programs because it's more comfortable for them, especially on Windows, to use these GUIs. So we'll get there, hopefully. But right now it's command line applications. And then these are what we call scripts and programs and stuff, and there are what we call batch applications. Yeah, that these are things when you have, it's usually command line. So you have lots of things to do, and you just give the computer and you can go away and it will do the number crunching and whatever it needs to do. Sometimes you hear people talk about scripts versus programs. There's no real difference. Some people think that languages like Python and Perl and Ruby, you write only scripts in there because they are not compiled, versus languages like C and Java where you compile the program. But that's, it doesn't really matter. From our point of view, it doesn't really matter. We just write some instructions in a language, okay? And then tell the computer to try to understand it and execute what we wrote. Whether you call it a script or a program, doesn't matter. I think Larry Ward, the creator of Perl, said that the difference between scripts and languages is that you give the scripts to the theater performer, and you give the program to the audience. So, but it's just joking about about people thinking that there is real difference. Okay, so yeah, next slide. I think we have our first code. So here, what I showed you already that you can go to the command line. So this Anaconda window, Anaconda shell window, and type in Python -V, and you get the version number. Or you could also write -- version, and that would be the same basically. There's also this example that I can show you that you could do, or people can do. People rarely write code just on the command line, but you could theoretically you could do, and this is not interesting. So basically, there's not many interesting things here. What we have here is that we switch to the Anaconda prompt that I mentioned earlier, and then we can type in Python V or -- version. These are the same. Or I think what I have there is we can type in print, and then I put here 42, let's say, and then it prints out 42. So basically what here I have is that I have this a little Python program in the parentheses, and this -C tells Python just take the whatever it is in the parentheses and compile it and run it, or understand it and run it. So usually people don't write anything like this. People usually create a file of a program. Okay, so let's do just that. Okay, here is the first example, and I'll go through it, and I'll go through how we are creating it. So the first example is called the Hello World. It's a quite standard thing to show in every programming language, to how to print something to the screen. And in some languages, it takes 2 weeks of study till you get here, and lots of understandings. Here you can do it after 10 seconds if I didn't talk so much about all kind of other things. Okay, so you have a file called hello.py, or doesn't matter what, .py, and the content is this: print, and then the parenthesis is hello world. And so you save it as hello.py, and then you can open the Anaconda prompt on Windows, or the terminal if you're on Linux or Mac, and change to the directory where this file is located, and type in Python and name of the file. Or if you have a Linux machine, then you probably will have to type in Python 3, because that's how it's called. Oh, that's one more thing that I didn't say. So on a Linux machine, you have the Python command, which is actually Python 2, and the Python 3 command, which is Python 3. On Windows, you usually only have 1 version of Python. It's called, the executable is called Python. So if you remember, I typed in here just Python, and this was already Python 3. So it's just, it's this way just to confuse people. Otherwise, it doesn't matter. So I don't think that we have a Python 3 here. No, okay? So on Windows, because that's the only thing we have, so it's called Python. Okay, so we type in Python the name of the file, and then it runs. Okay, so let's try to create this. So what do we do? Well, one way is that I go to the file explorer. I have this, I'm here in the C, Gabor, work, and then in the work, I just created a directory called work, a folder, and then I create another one, which is boot camp. It's just for, I am creating these directories just to separate things, okay? So I have, usually in my work directory, I have these subdirectories for each project I do, okay? And so now I have this one specifically. And in there, I right-click, I'm still not doing anything with the editor, okay? Right-click, and I say new text document, okay? And it created a file with new text document.txt. Now that's another thing I have to show you. So I change it to hello and .py, okay? It's gonna be slightly different for you, probably, and I'll show you in a second why. So now I have a file called hello.py. I right-click on it, and I can say edit with Notepad++. Okay? And then now I have the editor open, and here I can type in the program, print hello world. Okay, let's say with a capital H here. Okay, and I save it. So it's red now, just to be sure. And now I saved it with Control S. You could of course also save it with file save. Okay, but I'm used to press Control S, so I saved it. Now it's on the disk somewhere. Actually, I know where it is. It's in the C Gabor work bootcamp directory. So I switch to the Anaconda prompt. And here I have to get to this directory. So I type in CD, and now I am in the C users Gabor Sabo. If I type in CD and backslash, okay, so that's another issue. People are confusing. So this is called the backslash, and this is called the slash. Okay, and my standard explanation is that if you are in a jungle and you're trying to cut the trees, then this is the movement you do with your hand, if you're right-handed, okay? So that's slashing. And this is the backslash that you do the other way. Now, I don't know, some people get even more confused with this explanation, but that's the best I can do. So this is what people use. And you can see here, this is the backslash. This is the directory separator of Windows. Okay, and just go back for a second to the slides. you can see in the address bar, this is what we usually call slashes, or some people say forward slashes to make it even clearer that this kind. So this is what you have here. On Windows, you have the backslashes. Okay. So if I say cd backslash, then it jumps to the directory which is the C root, that's the root of the whole directory tree. And here I can say, let's say Gabor, right? Well, first of all, let's just say dir, and then you can see all the directories that are here, and including the Gabor that I created. So I cd into Gabor. Now I can type in dir. I don't have to type the dirs. I'm just doing it so you can see what's there. And now you can see that there is the Anaconda 3, which is the installation of Anaconda, and my work directory. So I type in work. Okay. Again, type dir, just so you can see. It's a bootcamp. So I type in bootcamp. Now I don't even type the whole name, the full name. That's another thing that the command lines usually give. So for example, here I started to write, and I press the tab key. And the tab key is creates, what is it called? I forgot the name. It comes word completion. So it completes the word. So if it needs, if it sees various names that starts with BO, then it will offer you the first one probably. And then you can press tab again, and it offers you the second one. And it circles through all of the possibilities. But in this case, I only had one thing that started with BO, and so it just completed the word. And it saves a lot of time and a lot of errors, because I never know how to type bootcamp correctly, okay, or most of the words. So now I'm in the directory, in the same directory that you remember here we created. So we had it here, okay? So this is C Gabor work bootcamp, okay? This is where we put the file. So now in the Anaconda, window, I'm the same. If I type in dir, then you can see that here is the file, the hello py. Okay, and now I can type in Python and hello, and again here I just type in H and tab because I'm lazy, and then I can run it, and it prints out hello world. Okay, so this is the first program. Now a couple of things that, at least in your case or in most people's case, is going to be a little bit different. For example, when you create a file, okay, so I have here, if you come here in the File Explorer and click on View, you will have here two checkboxes, file name extensions and hidden items. And they are both unchecked by default. So now this is how you probably will see. So now if I click on New and say text document, it won't tell me it's txt. So if I now create another file, and say, oh, I want the .py extension, what in fact I created, now I switch to this one, what in fact I created is a file called other.py.txt. Okay, so Windows is trying to be helpful here, hiding the extension, and it might be helpful for people who are not familiar with file extensions or not doing programming work. But for us, it's much better to be able to see the full name of the file. So I go to the view and I enable file name extensions. And there is also, some files are marked as hidden in Windows. So you won't be bothered by seeing all these files. And again, I personally prefer to see them. So I also turn on this hidden item. Okay, I recommend it, and now you can see that it's called other.py.txt. Okay, and it's better to call it .py. Now, why is it better to call it .py? Well, you can see here it thinks it's a py file, it's a text document. So if I double click on this one, okay, this didn't work. Whatever, I could do the mapping. So the thing is that you can map file extensions to some action. That's how Windows works. So when you double click on this one, it opens the notepad, the regular notepad. Now I can say that here, right click on this one, and well, I can say open edit Notepad++, but I think somewhere I don't know exactly now where do I have properties. Okay, I'll look for this later on, and I'll show you separately, certainly in the next video. How can you map that when you double click on a hello.py, it will, let's say, open the Notepad++. So it's going to be easier that way. But you can have this mapping to one, what happens by extension. And so what happens now if I open this with, well, I already have it open, right? So this is, I have it open. So what happens if I take the other file and right click and edit with Notepad? And I type in print hello, enough of typing. So what's the difference? Do you see the difference between the two? Right, the color.
Yeah, it doesn't highlight it with the different color.
Exactly, exactly. So this is what's called syntax highlighting. And the regular text, regular programming editors can highlight the keywords of programming languages. Okay, so, and the various elements of the programming language. So if I go here, you can see that print is blue, and when I get actually the parentheses, and it's red, it's really nice, and you can see the other side of it. Okay, here if I come, I don't know, the red, it turns on the red, but I don't see the print being a keyword. Okay, and the reason you don't see it is because the Notepad editor syncs. Well, here, okay, let's see. Here in the Python file, it says it's a Python file in the hello.py because it understands from the extension that it's a Python file. This one has the .txt extension actually, and the .py is just in the name. So the text editor, Notepad++, thinks that's just a normal text file. So it doesn't understand the print is actually a keyword. Okay, so therefore it's better now to close this one. And then whatever, F2, I think. Yeah, I want it to .py. So now it's going to be called .py. Now when I save it, that's another thing Windows does. Okay, so Windows tells you that if you're changing the extension of the file, you might ruin your computer or whatever it says. It's always like frightening. Don't worry about it. You're just changing the extension of a file. Okay, so now if I have this other .py and I edit it with, and now it's blue, because now it does the syntax highlighting. Okay, so that was at least one thing I wanted to say. What else is there? Do you have any questions here with all this part? Yeah, everything is fine. Okay, I don't think that I have any issues here anymore. So, but somewhere I thought that we are going to have an exercise. No, here are exercises. So I have 3 more slides, and then we get to the exercises. And the exercise is basically that you try to do it yourself, the whole thing. So we'll have a break with the video, and then we'll have time to do it. And we'll see how we proceed with this. But before that, before you do the exercise, and the exercise is not really just trying to make sure that your environment works as it is. Okay, so examples. I go back for one side. Here we have a really small example, but the way I do create the slides is that each of these examples is actually in its own file. It's not in the slide. Originally, it's in its own file, and then I integrate them together. And each file, the original name of the file, you can see it above it. So it says examples basics hello. And you can, I think these are, all of them are links. So you can actually click on the link. I do it with right click, so this window will stay. And it will bring you to GitHub, which is the storage of, it's a version storage. We'll talk about it later. The point here that it brings you to the actual source code of the file, which is really small here. And you could now, instead of copying from the slide, which might be problematic if you want to copy something, you can click here on raw and get it really the raw file. So this is the original of the file. Okay, this is one way you can do directly to go to the file. The other way is what we have in the next slide, is that you can go to the, follow this link, which leads basically to the same place in GitHub. Bit too big now, okay. So this is the URL called github.com/subgov, which is my username, and slides, which is this specific project where I have all of my slides. So you remember I have slides with Python and Perl and whatnot. So all of them are here, both the slides and the examples. So you can download this whole thing by either you can, once you know how to use Git, you can clone it and whatever. But as long as you don't, or you don't want it, you can click on this green button, I think, and you say download zip, and then you can download the zip, unzip it, and you get basically this same data structure, where each folder is one of my slide series. So you find Python, okay? You find here Python, click on it, and then here it's the examples folder. So now if you would like to find the where is this? I lost it here. The examples basics Hello Py, then here you can just go in examples and then basics and the Hello Py. So all of the examples are here. And this can be really useful because instead of copy pasting, so sometimes when you copy from the slides, the quotation marks get different and there can all kind of messes, or the tabs and spaces mess up. This way you can actually get to the actual source code of each file. Yeah, well, just let's forget for these slides for now. We have two more slides. Well, no, not this one. Okay, this one is still okay. Okay, so comments, you can add comments to your code. If you put in a hash mark and whatever comes after it is a command, it can come on its own line. It can come after an actual command. You can actually put the hash mark in front of a real command if you don't want it to be executed for now. Okay, so comments are used either to explain why did you do something there. I mean, if you put here printing out hello, that's probably not a good comment, because if someone doesn't understand that you're printing out hello, then it's better that person doesn't touch your code. But why you are doing it, or and of course more complex stuff also. Why are you doing it? Why are you doing it this way? These explanations are really useful, either for the next person who has to maintain your code, who is going to probably future yourself, right? You'll write some code and then a month later you want to improve it, or you'd like to fix some bug or something. And then you need to understand what did you do and why did you do it. So the what is relatively easily because you already know the programming language, and the why is the tricky one. So that's one thing that you put in comments. The other thing is that sometimes you have some code and you don't want it to run for now. Experimental reasons, or you just had this, whatever. You can comment out the code and then it won't run. Okay? And then, so let's just do this. I don't know why exactly do we have this slide here, but whatever. So in a program, in the end, it's just not enough to print out stuff. You will have to use what we call variables. So these are what I was explained, the way it was explained to me a long time ago is basically boxes where we put values in there. And in Python, it's slightly different, but let's say it's more or less the idea for now. It's good enough. So basically, we give a name to some value. Okay. So we say that this greeting thing will contain hello world. And then now we can use greeting in the print. And it's going to be especially interesting once we start changing these variables. Well, that's probably the reason they are called variables. So there is a number, we are increasing it, we are adding up things together, and that's going to be starting to be interesting. For now, it's just, I don't know, it's a straight it's a slide that just got here for some reason. Anyway, exercise. So now we're going to turn off the video, and then you can do the exercise. We have some break, and then we'll see in the next video. Okay, so see you in the meantime. Let me try to find again the